Well, I went ahead and started the recorder. Let me get back to my screen. And can everybody see my screen all right? Is that? Okay. And it's good to have your chat box open so you can try to catch. I have the chat box open, so I try to keep an eye on it. If you got a question, I'll try to answer it. If you see other people's questions and you know the answer, don't hesitate to go ahead and jump on it and answer it. I want to make this as, to have you participate as much as possible. Now, I did mute everybody, but you can always unmute yourself if you want to say something. That's fine too, to catch my attention. And
Mueller has accused him of working for the Russian government, being an intelligence official for the GRU.
Anyway, I'll try to keep everybody muted. And we'll go from there. With that, last week was really just a lot of review and getting comfortable with the course. I hope everybody is somewhat comfortable with the course and how it lays out and how it works. This week we actually will start some of the more relevant material in regards to the calculus. And although many of you will think of it as review as well, much of the material that we talk about is, yes, all the sessions are recorded. Yeah. At any rate, most of the material, even you see in this first week, should be, is most likely review from a good college algebra course. So with that, I think I'll go ahead and I should just open up my video just briefly. I don't know if you can see me or not, but I am live. I usually don't have my video open because it takes a little bit more bandwidth than I like. So with that, I'll shut off my video if I can get to it. And of course, every time I've got to go back to sharing my screen. And we're off and running. Okay. The first thing is just a quick, how do you calculate the equation of a line given a slope passing through a particular point? There's many ways or approaches to this. I kind of like to just think of, just in general, if you've got a point, x naught, y naught, and a line, and we want to know the equation of that line at, say, xy. One thing that you should quickly recognize is that this is just slope. So you could calculate your rise over your run. This little piece is this height is y minus y naught. And this run is x minus x naught. And this should just look like rise over run, the height over the delta x, or delta y over delta x. Many ways to think of it. Many of you just memorized the formula. And that's the slope. And what I typically do, rather than try to remember all of the formulas and the like, I remember the slope. I know what the slope is, and I can calculate the slope. And I know if it's going upwards, it's positive. If it's tending downward, it's negative, and I just go with it. In this particular case, I've got this point is negative 1, 1, and I know what my slope is. So I've got 4/5 is my slope, is equal to y minus the y point is 1 over x minus, and the x is negative, the x naught is negative 1, so it's x plus 1. And I can solve for y. So I've got 4/5 times x plus 1 is equal to y minus 1, or 4/5 x plus 4/5 is equal to y minus 1. I can add the 1 to both sides, so I end up with y is equal to 4/5 x plus 1 4/5, or 9/5. And I'm done. This is the slope-intercept form of a line. And this is the point-slope form. And I'm just going to let it go at that. That's just sort of a quick review of calculating slopes, and just using the definition of the slope of a line to get the equations of the line. Any questions on that? Hopefully that's all comfortable information. The next problem is just functional notation. A lot of students struggle with this a little bit. So I'm just going to just do an example. We've got s of t is equal to 7 minus t squared. So that means like s of 0 would be 7 minus 0 squared, or 7. And s of 1 would be 7 minus 1 squared, or 6. And s of 2 would be equal 7 minus 2 squared, which is equal to 7 minus 4, or 3. I think you get the idea. Whenever you plug whatever's here, you want to evaluate it at that particular point. You plug it in for the t and you go with it. It's a substitution problem. Here we want to find s evaluated at x minus 2. Well, you do it the same way. S evaluated at x minus 2 is going to be equal to 7 minus, and wherever t shows up, I'm going to replace it with x minus 2. Now, technically, I'm done. There's not much more to do. If you want to go ahead and multiply it out and simplify it to see if there's a multiple choice answer that matches or whatever, then absolutely, you've got to do a little more work. 7 minus x minus 2 squared is x squared minus 4x plus 4. So this is equal to 7 minus x squared plus 4x minus 4, where I've distributed the negative sign through. 7 minus 4 is 3, minus x squared plus 4x. Now, usually you put the x squared first, so I'm just going to rearrange it. Negative x squared plus 4x plus 3. But that's whatever. Some people arrange it the other way, 3 plus 4x minus x squared. If you work with Mathematica, that's what it is. So that's functional notation. Again, I hope that's just a quick review. It's some of the problems that you'll see this week. Average rate of change. Don't let average rate of change be a big deal. I don't care what the function is, y equals f of t, whatever it might be, it's a function of time. And let's say we've got it graphed. And let's say this is the point A, and over here is the point B. And this is my time, and this is my output, y, whatever it might be, whatever the variables might be. A lot of this unit also talks about the variables and what they mean. You know, when you're looking at, and maybe I'll do that. I'll add that as part of this problem. So if I come up here, this point right here is A, and F evaluated at A. And this point up here is the point B, and F evaluated at B. Now, the average rate of change is nothing more than a fancy way of saying, calculate the slope. That's it. The average rate of change is the slope between two given points. So you've got to have two given points. In other words, the average rate of change, if I want to calculate the average rate of change of F between t equals A and t equals B, what I'm basically going to do is calculate the slope between the 2 points. Or f of B minus f of A over B minus A. Hopefully that, you know, should take all the mystery out of it. I mean, that's all it is calculating the slope. A lot of calculus 1 is just calculating slope. Now, to put some units on this, let's say F is in dollars. And the input is in years. So it could be some profit or whatever it might be. What's the average rate of change of the income of a company? Something like that. Well, what's the units on this slope? Well, the change in the Y values would be in dollars, and the change in the T values are in years. So the units of this average rate of change, or the units of slope, would be dollars per year. Thus the idea of a change, a rate of change. How many dollars per year does it change? Hopefully it's, you know, when you break these things down and look at some fundamental ideas, hopefully they're, you know, hopefully you don't get scared off by them. They're just fundamental concepts. Any questions on that? All right. Now, relative change is a little bit different. Usually, what you have is, well, let's just do our y equals f of t again. Usually, you have some initial point or population or something like that. And the initial point is typically when t equals 0, typically. you need some initial starting point. And so I will call it why not. Why not? And that's just f evaluated at 0. And the relative change is going to be of the form, the change over the initial value. For instance, the relative rate, the relative change between, let's say y1 is equal to f evaluated at t sub 1, whatever t sub 1 happens to be. Might be 1 minute, might be 1 year, it might be 5 boxes, whatever it might be as far as the units are concerned. The relative change between y sub 0 and y sub 1 is y1 minus y0 divided by y0. It's just this little ratio, whatever it might be. So when you run into that a little bit, that this might be a little bit of a new concept that you haven't seen, but it is fairly useful, particularly in economic ideas, and we'll get into that. Okay, I just wanted to throw that out because that might be new. This is another review concept or a review idea. It deals with characterizing graphs. I might have something that looks like, let me do this. Notice if this is y equals f of x, notice between a and b, or a and c for that matter, the function is tending upwards. Because it's tending upwards as we go from left to right, we say it is increasing. So f is increasing on the interval I'm going to go ahead and close it, AC. Make sense? Is it decreasing anywhere? Well, it might be decreasing a little bit in here. I fudged it a little bit. But I'm going to say it's increasing from A to C. Okay, it's decreasing nowhere on AC. Concave up. Concave up means if you have a bowl, it's pointing upwards. It's open upwards. And concave down means it's going downwards. Notice the function is increasing everywhere, but at some point in here, i.e. like at B, we're concave up, and between B and C, we're concave down. And these are just sort of general ideas to, and if you got a good handle on these, it'll make the calculus going forward a lot easier to visualize, which in essence makes it a lot easier to do. So F is concave up on the interval A to B, and it's concave down on B to C. Any questions there? Are we all good? We can say yes or something. Then I know I've, all right. Or type yes in the chat box or something. All right, so curve characteristics, you most likely saw these ideas in a college algebra, Math 22 type course. It's good to maybe brush off the graphing ideas in that course, and we're good to go. Okay, this particular problem starts to move into exponential functions, and in this first unit, students have a tendency to struggle with it a little bit. So we've got this exponential function, p is equal to p sub 0 a to the t. By the way, p sub 0 is the initial condition. It's initial condition because if I were to evaluate p, and if you want, I could put p of t. P is a function of t. If I were to evaluate p at 0, a to the 0 power is just 1, and I'm left with p sub 0. It's your initial condition. It's the place you start with. Okay, what we're given here is this function, this exponential function, and we're given 2 points. We're given that p is equal to 225 when t equals 1, and p equals 300 when t equals 5. And we're asked to determine p sub 0, that initial condition. Well, we don't know the function. We just can't go in and evaluate it. So we're going to have to come up with what is a. How do you calculate a? Well, we're going to use the information that we've got. Notice when t equals 1, p equals 225. So 225 is equal to p sub 0 a to the 1 power. Notice I just plugged in the numbers, plugged in the point. That's a given point. We're also given that p equals 300 when t equals 5. So we've got that point. Now we've got 2 unknowns and we've got 2 equations. And we should be able to come up with values for each of these 2 unknown constants, p sub 0 and a. Well, the approach I'm going to use is, since 300 equals p sub 0 a to the 5th, and 225 is equal to p sub 0 a to the 1, notice that if I divide the 2, if I divide 300 by 225, but instead of dividing the other side by 225, I know it's equal to p sub 0 a. Notice the p sub 0s are gone. And I'm left with 300 over 225 is equal to a to the 4th power. This is looking encouraging because now I've got one variable, a, and it's equal to something. A to the 4th is equal to something. Well, if I take this to the 1/4 power, and if I take this to the 1/4 power, a to the 4th to the 1/4 power is just a, and I've got a value for a. So I'm going to come over here and go to my calculator, and I would go parentheses 300 divide 225 parentheses 2 the 1 divided by 4 power and enter it, or equal. And when I did that on my trusty calculator, I got 1.075. Now I want to say, when you're doing homework and the like, you know, we have no issue with you utilizing a calculator. Many of the self-assessments ask you to use a calculator. However, on the exams for time, and since it's multiple choice, we don't simplify them. We just simply leave it at, for instance, this stage right here. So on an exam, you won't have a calculator. However, the problems are such that you don't need a calculator. That's what I'm trying to say. But there are reasons to go ahead and calculate this out, whether you're using a spreadsheet or whatever it might be. And we now have a value for A. And by the way, this is an approximation. It's 1.0746 something. So it's approximately 1.075. Now, what do we do with this information? Well, we can come up here now and evaluate P sub 0, because 225 is equal to P sub 0 times a to the 1 power. So if I divide 225 by 1.075, I'll end up with P sub 0, which I got 209. Any questions there? Now this problem does show up, and it typically ends up in the discussion column. How do you do this? That's one reason I thought, well, I'll just walk through an example and just do it for you. And of course, once you've got P sub 0 and A, you've got the whole function for any value of t. And that's it. That's all I had tonight. Short and sweet, 30 minutes. My sessions usually are short and sweet. I typically will spend a little bit of time on the prior a week issues, if I see any issues that a lot of people missed. And then I'll throw out some ideas for the following week. Now, be sure, Kasia has her session. I believe it's on Thursday. She'll go over lots of problems for you to really help you set up. If you have an opportunity to do some of the problems before her session, or you're able to ask her some questions or post them, she'll get to them, and she's very good. And then during the weekend, I think you got an email from Olivia today, or Liv. She's also a very good guided study group leader, and is it's worth it if you've got questions to see her approach to it. And but at least I hope I got you off on a good foot for the week. With that, I think I'm going to turn off the recorder and bid you all a good evening.